Welcome to Study Loop.
So problem 8.51, we have 3 blocks of chocolate, and we're told the mass of each block. It's quite a lot of chocolate. And we're told the position, the x and y coordinates of the center of mass of each block of chocolate. And what we'd like to find is the center of mass of all 3 of the blocks. Both the x and y. And that's a C now. So, for example, the x-coordinate of the center of mass of any number of objects is this weighted average of the positions, and they're weighted by the masses. So this is the weighted average of the x-coordinates, where I goes over however many things there are. And just in general, a weighted average, you take the thing you're averaging, multiply it by whatever the weight is, add all those up, and then divide your sum there by the sum of all of the weights. And you can convince yourself with some simple examples that in the case of just equally weighting everything, call this 1, that this works out to be, because then this will be n if you have n objects. Or if you have like 2 or 3 or something of the something and you don't want to write out all of those, you could multiply it by 3, say, times whatever it is that it has 3 copies, and then it all sort of works out. And then this still works for fractional weights and so forth. So in this case, for our x-coordinate, we only have three things. 1, 2, and 3. And if you do this arithmetic here, you get that the x-coordinate of the center of mass is 0.0444 meters. Now the same thing applies to the y. Nothing is really different here. Imagine replacing the x with y in here and you get the same thing. So m1y1 plus m2y2 plus m3y3 divided by the same sum of the masses, because the masses we were weighting the average with were the same. And so then this you'll find is 0.0556 meters. So if we call R our position vector, then we can see that this is located at 0.0444 meters, comma 0.0556 meters.